Hello and welcome to one more tutorial on using timer interrupts on the Arduino Uno. In this tutorial, we'll not be using timer interrupts directly, but instead understanding the functions of analog read and PWM. We'll need a breadboard with necessary power supplies, a potentiometer to demonstrate the analog read function, jumper cables and an LED which we will drive using PWM. The setting of the potentiometer will decide the brightness of the LED. So the important concepts that we will be covering are analog read. So basically, while the Arduino pins can read digital signals of on and off, they can also read analog signals, and these analog signals are scaled to a value between 0 to 1023 using an internal analog to digital converter. Map is a function which maps one range of values, say from 0 to 1023 to 0 to 255. This function is required because while the analog read function of the Arduino traverses a range of 0 to 1023, the PWM pins can go through a range from 0 to 255. We'll also be seeing the use of serial print in diagnostics. So here are our connections. As you can see, there is a breadboard. On the breadboard, we have connected the MB102 breadboard power supply module. This will be powered using a 9-volt adapter. You can also power it using a USB cable. We have a potentiometer which we have plugged into the breadboard. One terminal of the breadboard is connected to 0 volts and the other terminal is connected to 5 volts. The mid terminal of the potentiometer is connected to the A0 or analog read of the Arduino. I have also connected an LED and a resistor. The connections are explained in detail in a practical demo. So here's my MB102 in detail. As you can see that it can power two rails, one on the left and one on the right. You can see this plus symbol and this negative symbol. And here are certain jumper selectors. So if you pull out this jumper and plug it in here, then you will get 5 volts. If you plug it in here, you will get 3.3 volts. You also have a power on button, a USB power in and a barrel jack. Here's our Arduino in detail. So we'll be using the A0 connection, the ground connection and the pin number 6, which basically corresponds to PWM. You can use any of the other PWM pins also, like 9, 10, 11, 3, etc. So here's our shopping list. I have put some links in the description box. There is this 9-volt adapter, a breadboard, MB102 breadboard power supply, which is convenient to have, jumper cables and a potentiometer. When you get jumper cables, it's convenient to get these jumper cables, which are kind of neater when you lay them on the breadboard. As you can see that these jumper cables come along the surface of the breadboard, which makes it more aesthetically pleasing. You can use a few longer jumper cables which go to the Arduino Uno. Let's now shift to our code. So here's our code. I have declared a variable called integer adjust, which pertains to A0. This stores the value which is read by the analog input. A variable LED is defined as pin 6. Then there is an integer adjust value which is set to 0 and an integer PWM which is set to 0. So when we do the setup, we set the serial.begin to 9600 to enable communication between the Arduino and the PC. The pin mode of the LED is set to output. So pin 6 is set to output mode. So we are running a void loop which basically repeats every 1 second because of this delay. And what we are doing here is that we are going to do an analog read on the value at A0 and store it in the variable adjust value. And this adjust value is going to be mapped from 0 to 1023 to 0 to 255, and that goes to the variable PWM. The variable PWM is analog written to the LED pin, and that causes the LED to flash. So the purpose of this code is to flash the LED at a rate that is proportional to the value read by the analog pin. And just for diagnostics, we'll be printing this value to adjust val. Please note that once your code starts to work, it's better not to have statements like serial print, because serial print delays the void loop considerably. Now we move on to the actual setup. So here's our setup. I have a 9 volt power supply which I have connected to the MB102 breadboard power supply. This basically can power two power rails. So here's positive and negative, and this powers this power rail, and here's another connection which powers a second power rail. There are two power options in MB102, 3.3 volts and 5 volts. So the jumper on the right has been connected to 3.3 volts and the jumper on the left has been connected to 5 volts. So on the right I will get 3.3 volts and on the left I'll get 5 volts. Let's check this out by connecting it to a multimeter. So here we go. The reading on the right rail is 3.3 volts approximately. The reading on the left rail is 5 volts as per our jumper selection. So now we are ready to connect the Arduino to this. So on the breadboard I have a potentiometer and here are the jumper cables. So this jumper cable connects one terminal of the potentiometer to plus 5 volts. This connects the other end of the potentiometer to 0 volts. And here's the middle terminal, the one on which the voltage would vary as we rotate the screw. And this I am going to connect to the Arduino Uno's A0 port. You are free to use any of the analog input ports of Arduino. The next step is to have an LED that's connected in series with a current limiting resistor. The negative end of the LED is connected to the same ground terminal, and the positive end I am going to connect it to port 6 of the Arduino. You are free to use any port, but for the purposes of this experiment, you should connect it to a port with this symbol next to it, which basically indicates that the port is capable of pulse width modulation. The last and the most important step is to connect the ground of the Arduino to the circuit ground. This makes sure that the ground, the entire circuit, the Arduino, the potentiometer as well as the LED, they are all on the same common ground. Don't get confused by this plus mark. This is provided by the breadboard manufacturer. But if you see the way in which we have connected the MB102, the top rail is actually negative and this is positive. So now we connect the Arduino to the PC. The Arduino is selected and I am ready to flash the code. The code has been successfully flashed. I once again turn on the power supply. So as you can see on the serial monitor, the reading is 1023 and the LED is at its brightest. So I use a screwdriver to turn the potentiometer to a lower value. Now the reading is 941 and the LED is slightly less bright. I turn it further and the brightness of the LED further reduces. The reading on the serial monitor now is 641. Now I decide to turn it a little bit more. The LED is even dimmer now and the reading is 280. I can even turn it off completely. I take it down to 0. The reading on the serial monitor is also 0 and the LED is also turned off. So this completes our experiment. What we are doing here is that we are using an analog input to the Arduino given by this potentiometer, scaling it up inside the Arduino and using that to drive a PWM signal to this LED, and that decides how brightly the LED is going to shine.